back to Crypto Bits. I'm your host, Brittany, and today we have two very special guests joining us. Attila Aros, I hope I'm saying that correctly, will be helping me co-host the show today. Attila, how you doing?
Hey, I'm doing fantastic. Thanks. How are you doing?
I'm doing great. And we have David Lancashire, I hope I'm saying that correctly as well, from the project Saito. And I am just so excited to get into this today with you guys. So David, could you start us off real easy and just explain to Attila and I what Saito is?
Real easy explanation of Saito or Saito. That's a bit tough. The shortest version is that we're an L1 scalable blockchain. So what you want to use Saito for that you might not want to use other networks is if you want the universal broadcast properties of a network, of a blockchain. So you want your data to go to everyone, and you want your data to be attached to transactions. That's what we're good at. What makes us different is that we solve the scalability problems on a much deeper and more economic level than a lot of people even conceptualize it. And that's actually not something that's super easy to explain, but I'd love if we could talk about it.
Definitely get into that a little bit more in just a second. But I wanted to ask you, what does the roadmap for Saito look like over the next, let's say, 5 years?
We just got a roadmap out that's showing probably the next 2 to 3. Our focus is not on it's not starting as a digital form of money. So basically applications are going to be rolling out on Saito, and those applications will involve support for other cryptocurrencies. So we're going to be trying to support getting applications up on a bunch of things. We've got friends in the DOT community. We have friends in the BSV community. A couple of other communities. And so we're going to be trying to get applications out that let people really, really easily build in-browser games, productivity tools, whatever that integrate with the cryptos that they want to use. And so Saito's kind of starting as a supporting there for applications. And as transaction volume grows and fee throughput grows, the security of the network grows as well. So it's kind of an applications first, store value later approach, which is a weird opposite of kind of what you see with a lot of proof of work coins.
That's definitely interesting. So the next question I was going to ask is, what are you looking to accomplish? But I think that really sums it up in a nice little neat bow right there. But
just jump in. It sounds like Saito is really focusing on utility. Like you said, applications. It's really about actual utility instead of the store of value. And that's something that's been really missing with the other blockchains, is that it goes the other way around. So I think that's a really good thing.
Yeah, I think it's also a requirement of some of the design considerations we can get to, because by solving economic problems, one really interesting thing about Saito is there's no block reward. The economic design is such that, there are problems in proof of work and proof of stake where there are many situations in which an attacker can get more money out of the network than they put in, right? If you can get 51% of hash power, or if you can get 51% of stake, like the cost of attack is supposed to be imposed for attackers, it's supposed to be more expensive to produce 2 blocks than the honest network, which only produces 1. So cost of attack kind of comes from that, but the result of that is that there are situations in which you can actually do that. And when you can do that, you can, 51% of expenses can buy you up to 100% of network revenue. So there are things like cartelization. A lot of this stuff is incentivized. And what Saito does is the economic problem. One of the ways to think about it is it prevents people from ever being able to get more money out of the blockchain than they put into it. And we can talk about this specifically, but it's basically because the measure of work that we use isn't in an external market. So we're not sending people out to buy hash, and we're not sending people out to buy stake, which is kind of like, it's kind of like sending people out the back door and you can't really see what's happening out there. So if there's cartelization, if people are renting hash, if they're buying it or they're just polluting, you don't really have any visibility into that. we use, our work function is based on tracking how money comes into the network. And so everything is kind of under the gaze of consensus all the time. But dragging it back to the question, what this means is we can't have a block reward, because having a block reward would be giving free money to someone, and it would be enabling economic attacks. And the entire point of consensus is that we don't do that. So it puts us on a very different track and a very different development model, because we have to be applications first, because we need to get transaction volume up before anyone is going to look at the network and be like, I'm willing to keep some assets in here long term.
That's really interesting that you say that the block reward enables those attack vectors. And I'm curious if you had was there any like key aha moment or insight that led you to discovering or inventing this novel consensus mechanism, or was it just an incremental thing? I'm curious about the process of coming to this.
I mean, the solution and the approach came in the spring of 2017. And the problem that I think there was an intuitive perspective that we had to actually pay people in the routing network, because, if you give all of the money to the block producer, there's just there's a window, the 51% attack is there. There's a lot of attacks. Yeah, I'd say it's a combination of intuition, but I think the intuition started at the right place. The process of coming up with it took about 3 weeks. It was really, really hard. Maybe we can talk about it. It's a tough question to answer. Like, what's the starting point? The critical thing is realizing we're playing a game with money, right? A lot of people don't think about blockchain this way. A lot of people say like hash is difficult, or hash is expensive, or, like stake, you can never get all of the stake. And, they're taking some mental model of what hash power is, and they're kind of implying it's not economic. And that's never the case if we're actually thinking about free markets. Hash power is becoming an economic commodity. It's becoming something you can rent. We saw that actually with the BCH BSV fork, where who is actually renting hash going into this. The fact that people were renting hash tells you a lot. So you've got hash power that's potentially becoming a rental commodity. You've got stake, which is, what's the supply curve for these work functions? For stake, it's basically the willingness of people to sell it at any point in time, because it's literally money. With hash power, it's kind of like, you've got the same thing, but the supply curve is also driven by research and development and the costs of actually getting these marginal efficiency improvements in hashing machines. So I think like proof of work is in some ways, I think, much more secure than proof of stake. But, the starting point for Saito is realizing we don't think that that's actually a good way to think about blockchain, because we think in the long term, all of these work functions are going to be fungible essentially with money. And that leaves us with, like Craig Wright, I think you guys are in the BSV space. He's commented about how proof of work dies when when we hit the end of Moore's law. I think it actually dies a lot sooner, because if you look at CPU, if you look at like the trends in CPU research, the cost of every marginal improvement in CPU efficiency, which is a good model for mining equipment and how much it's going to cost to get those efficiency improvements continuing to go, like it keeps going up. And the block reward, meanwhile, is going in the opposite direction. So, it's really, really bad news for BTC, but it's bad news for proof of work chains that are hoping to scale this way too. So, with Saito, the starting point is saying, well, actually, people might think that, but that's not true. Forms of work are ultimately fungible with money, because we have a free market at play. And the result of this then is we have to have an economic consensus mechanism that works basically by getting rid of the ability to play money games where you can pull more money out of the system than you put in. And it's really abstract, but you can think about the scaling solution in this way. The most scalable blockchain is the one that has the least leakage. Which means it's the one that doesn't let people play these games where they can focus on the things that don't provide scale, but that benefit them by maximizing their private income.
Yeah, I definitely think that with BTC, it's a bad thing. With BSV, it's a little bit different. With we're not so focused on like the block rewards so much as we are making money off of the microtransactions, and producing an economy that way instead of miners focusing so much on the block reward subsidy like on BTC. But I definitely I want to hear a little bit more about the way that Saito. You talked about Moore's law. Can we jump into a little bit about that real quick and explain to
Sure.
me what that
Well,
is?
Moore's law is when you can, if the slope of the supply curve, let's think of it this way, the 51% attack, there's really two attacks here. And if you go to websites that are saying, what is the cost of attacking the blockchain? A lot of them are saying, well, that's the cost if you had to rent or if you had to buy this much hash power at market price, right? Like you're not in the network and you have to buy that much. Now, when we hit Moore's law, when hash power basically becomes an economic commodity, like any other economic commodity, if you're willing to pay a slight premium, you can get as much of it as you want. Now, BSV is practically already quite insecure on this front because it doesn't really have much hash power. And the network has also resorted to kind of proof of social media in terms of defending forks. And that's actually interesting because you can see the problem. You can see one of the problems right there, which is why don't you let the attacker dictate the fork? Well, because if they're doing this attack, they're making money while they're doing it. On Saito, that wouldn't be the case. On Saito, if someone actually started a fork like that, the honest network actually wants them to continue and then continue when they stop burning money because the attack is literally transferring cash to everyone else in the network. Pulling back to Moore's law, what you've got is you've got a supply curve which is originally quite steep, and that flatlines. So all of a sudden, you've got 100% of network revenue, and network revenue is what determines how much hash you have. Because if you ever have, the network will not spend more money than it can possibly collect in hash power. So 100% of network revenue buys 100% of hash, or it's something like that with 97%. There's some margin in the market for profit. But what that means is, one, when the supply curve becomes flat, when hash power becomes a rentable commodity, and there's already things happening. I think Slushpool is setting up a futures options for hash power. So the people that are investing, hash power is commoditizing. The question is, how quickly is it going to happen at what scale? So as soon as it really flatlines, well, it's quite easy for someone to pay for hash power rentals. Money and hash have just become entirely fungible, and the fundamental assumptions in proof of work of security kind of disappear on that front. The second observation to make is that all of these websites that are saying, oh, well, you have to rent this much hash power, you have to buy this much hash power. Well, we've already got 100% of hash power on the network in existence right now. So it's not even necessarily a cost of attack. It's a question of how easy it is to pull off collusion with other participants in the network and how in the real world that happens. And I think, previously we mentioned BCH, I think in the pre-show chat. And, if you've got a mining parliament, a lot of the instances with collusion, it's presented to you as something that's good for the network. And what it does is it prevents new people from coming in, and you've got attacks. And, the point is that it's possible today. It's possible on any proof of work and proof of stake chain. The question is, can people pull off collusion? Because if you can pull off collusion, then your 51% consortium can collect up to 100% of network revenue, and there's no difficulty with the supply curve at all. You might just have some trouble masking it. And some of the things you can say, well, what would we expect to see? We'd expect to see network consolidation with miners. We'd expect to see a real difficulty in new entrants coming into the market and competing on equal terms. And I think we can see this in a lot of proof of work and proof of stake chains. Whether this is the cause or something else is, over the long run, the idea that proof of work is going to have a really steep supply curve for hash power, I think is just wrong. Does that answer about Moore's law? Because Moore's law is like, it's as good as it gets. And so, these hash power chips, you can pick them up on the street,
Just on taking from there, it sounds like in a lot of ways the proof of work was this bootstrapping mechanism to establish this space, and that it's going to be a transitionary period towards something else. Do you see Saito as that kind of soft landing that would interoperate with other chains, kind of support this transition to a different consensus model? How do you see Saito kind of preparing for that? We'll call it the Moore's law flatlining.
I mean, we're not susceptible to it. We're not threatened by Moore's law, and the reason for that is that there's no 51% attack. What we basically do is, if we go back to the basics, where in proof of work and proof of stake, the cost comes from the fact that the attacker needs to produce 2 blocks in the time that the honest network needs to produce 1, right? That's leveraged to impose the cost of attack. And the idea is that if everyone is spending their income on mining, then the attacker has this sharp hill to climb. With Saito, we actually make this really interesting observation that no one else in the space does, which is if you are an attacker in one of these networks and you are putting a transaction into a block, and that transaction getting included in the block is profitable for you, if it's profitable for you, it's not your own money. And we observe that if it's not your own money, you are now +1 hop deeper into that network than at least one honest node or user. And what Saito does, this is really abstract. So I don't know if this is going to make any sense, but I'm going to continue because we had a great conversation, Attila. So hopefully hopefully people will follow. What we do is we say, well, look, as transactions pop into the network, we're going to put a tax on them. Each transaction is worth less for making a block. And when that transaction goes into a block and the block comes out, when that payment is issued, you're going to get less money out of it as a result too. So what the network is doing on an informational basis is it's taxing block producers that have to use these really long routing paths to compete to make a block. And that's what an attacker is. And so we've still got this longest chain mechanic, but we've also got this other informational observation that is used to tax attackers inside consensus. And that's where the 51% attack disappears. It's kind of like if you're an attacker and you're taking fees that the honest network has collected and putting them in your block, like they're half as useful for buying hash power. And this is where, the analogy of going out to the supermarket behind, the shed, well, that's where the 51% attack is coming from. It's coming from the use of an external market and assumptions about the nature of the work function in that market. And Saito says, look, it's all money. So what we've really got to do is we've got to track how the money is moving around, and we have to have a work function that consensus can keep its eyes on and tax attackers in a way that honest nodes don't care. And that's why this tax works, because basically the way Saito works is the tax is paid out of the transaction fee. And if you're an honest node and you're routing transactions that have been paid and made by honest users and other people, you don't care if you're paying a tax out of that. I mean, you might care if you're on a really long routing path and the tax is huge because you don't want a really long routing path. But you're okay getting taxed if the money is coming from someone else. If you're an attacker, though, you can't use that money to make blocks and get paid because you're going to do it at a loss because of the way that the tax works. And that's the really difficult thing about Saito that kind of blows people's minds when they look into how the math works. But maybe at a high level, this kind of explains. Brittany, did that make any sense?
I'm following along. I'm still digesting, but I am understanding the basics here, what you're trying to convey, for sure.
There's no Moore's law in this vision because the tax doesn't depend on hash power being difficult. The tax works like, at the end of the day, if you get $5, it's $5 or however much hash it is. It's got to be expensive, but it doesn't need to be difficult in the sort of abstract way that people have decided that like hashing is difficult or that staking is difficult. It's pure economic tax. And this maybe gets back to the application side of things, right? Like at small transaction volumes and small fee flows, Saito itself is insecure because it's easier to do a chain reorg. So, getting back to your question about other networks, we actually see the problems in networks like proof of work and proof of stake. We see Saito as kind of buttressing against them. And the proper model for really scalable networks is, if you're proof of work and proof of stake, for economic reasons, you are going to be consumed alive by the economic forces that are being unleashed. And we can talk about this, what the problems are. If you have a Saito network on the outside and you have an application layer that is running on Saito for economic reasons, we can actually keep this monopolistic collapse from killing your network. So we think that what's going to happen is, at least for the next decade or so, this is how Saito will grow. It's going to grow as an application layer, and it's going to grow in supporting other blockchains. And it's why Richard and I are working on this. I mean, we've been in crypto for some time, and there are a lot of people that do stuff because get rich quick, whatever. It's like, actually, this is difficult. We're in this to make this a reality. But yeah, it's kind of leaning things against, and then in a decade we'll see. I think long term there's a need for every blockchain to pay for its network, and I think that long term the question is not will the techniques that we are introducing be used. The question is how will they be integrated, depending on what happens with proof of work and proof of stake. And maybe pulling it back, you asked about how we fit in the landscape. I'd say the real question is about how public blockchains, meaning blockchains that desire openness and desire non-permission participation, compete against what's getting thrown out in proof of stake circles and the consensus mechanisms in the states, where it's all going to just be a permission corporate chain. And maybe there's 2 people running it, maybe there's 3 people running it, but at the end of the day, it's not open. And we don't know the answers to that. I mean, we think public blockchains are really important because, to us, that's the thing that Satoshi invented that was new. And if we get rid of that, we go back to the 80s,
It's interesting because the way you describe how Saito would kind of sit alongside other public blockchains and kind of grow alongside to be that application peer-to-peer layer. We see this in BTC with the Lightning Network and the challenges there. Do you think that Saito would excel in that kind of capacity of like replacing what the Lightning Network is doing and kind of supporting that facilitating that those higher scalable transactions? Is that the kind of where Saito would fit in? The logical conclusion would be to be that sort of, I don't want to say L2 solution, but a pair solution, both for both blockchains.
It's a tough question, and there are so many approaches people are taking. You can use a Saito style network to do things like the Lightning Network, right? Like Saito, it's a universal broadcast network. So the routing issues with LN go away. We look at the scaling approaches, whether it's layer 2, DAGs, things like Avalanche. And what we see from the Saito perspective is everyone is sacrificing openness, or they're sacrificing the property of data availability and universal broadcast. And people are doing this, and they're coming up with networks like Avalanche. It's a consensus system. It's not even, it's not an economically self-supporting network. These guys literally are taking us back to Lamport style systems in the 80s. And, the things that were really important about Satoshi's invention is it's permissionless and open, and everyone can join. And that's like section 1 on this is the heart of our critique of BSV, by the way, is that it's advertised as the original economic design, but it's really not. They're replacing a volunteer peer-to-peer network with a commercial network. They're getting rid of the first requirement in section 5 of the white paper, and they're trying to gaslight people about how this is actually the original design, and it's not. And this is kind of getting to the economic issues too, which is what happens to your network when you take a volunteer peer-to-peer layer, because that's what's protecting open access of data flows, and when you give this to companies. Yeah, anyway, this is, you guys can trigger rants pretty easily by asking these questions. I'll throw it back to you. I don't even know if you got an answer. You got a rant there.
To me, that sounds great. We'd be able to, like, the way you described it with like this universal broadcast network, I really think really frames like a key high level application of this that really can apply to any other blockchain and support. And so I really see that as a strength, because it's like a complement to everything else. It's not, you're not playing this winner.
Public blockchains, right? Like DAGs, they get rid of that property. And when people are looking at, scaling with sharding and stuff, they're also getting rid of that property. People are trading off, and so people come to us sometimes and they're like, well, let's talk about scalability. And they're like, well, this is, what's your transactions per second? What's this? Or they're, and they're using approaches that don't do this. And it's like, well, yes, if you get rid of universal data broadcast, there are a bunch of these like micro, where they use commutative encryption to, you have a micro blockchain and stuff. You can't attach data to those transactions like Mimblewimble. I don't see how you could do it. It's great if you just want to exchange tokens. But if I want to do a Diffie-Hellman and SIG exchange with you guys, I can't do that on that blockchain. And if I can, it's like, well, how is that supported? And they're like, well, we'll use IPFS. And it's like, anyone who's talks about IPFS, it's like, please go away, because like, you don't have an economic model. You've got, like, you're going back to volunteer provision. And it's like, if volunteer provision worked, we wouldn't have this problem.
It's interesting you talk about the the IPFS and off-chain data and there's on-chain data. I'm curious what your thoughts are in like the current possible throughput for Saito, and like what enables that, and in terms of like large block sizes and how big transactions can get. I'd just like to hear your thoughts on like what you think the current limits are, if there are any, and what would drive that, the scalability of Saito.
The current limit is trans-Pacific. If you look at actually having a global blockchain, the Pacific is the slowest. So it depends on that sort of thing. What I'd say is on-chain, off-chain. Well, every blockchain can have this layer 2 off-chain support. Our focus, if we're building global and public scalable networks, has to be on given universal constraints that come from physics, right? Like the speed of light, that come from, if I'm installing a router, like literally how many terabits per second, that tech is going up. Amazon, people are hosting these days on S3. A lot of those networks, DigitalOcean, you're capped out at 25 megabits per second. So those networks can't really scale. They have to use compression techniques in order to up their, up their transactions per second. We're focused on the economics, and so we're not taking shortcuts with this stuff. We're saying, look, we're facing these physical constants. We're all of us facing the same cost at a certain network size, at a certain amount of data getting passed around. And what we need to do is we need to make sure that the people who are spending that money, that people are incentivized to spend money on the right things. So one of the consequences, for instance, is, Brittany, you mentioned things like the block subsidy before. And it's like, well, I remember reading Craig Wright's piece, The Great Mining Swindle, where he complained about how, miners were not understanding their own incentives. And it's like, that's not a statement an economist is going to make, because of course people understand their incentives. And people are literally behaving in a way that maximizes their private interests, right? Like there's a fundamental problem with economics that very few people in the BSV camp understand, which is that like people like to reason backwards from these ideal situations where like we know what the best possible outcome is, and people will do this because it leads to social wealth. And it's like, that's not how a free market worked. If that's how a free market worked, the state would literally not exist. We would all have public health care, national defense, education. There'd be no such thing as public goods. In a free market, people do what's best for them. And there are a lot of incentive structures where even though you know what the right thing to do is, you still end up in a really bad spot because people are focused on doing what's best for them. So, you know, proof of work, this is one of the issues with proof of work and why we say it's really not scalable, because, well, miners have an incentive to hash. They don't have an incentive to run the network. And what we're seeing, you know, why is Saito more scalable? It's actually running that network equipment is the equivalent of hashing. Because if you don't run that network equipment, you can't collect transaction fees. If you can't, and the way you collect transaction fees is by being on the edge of the network and having the relationship with the user. And so the challenge we've got economically in terms of kind of anti-competitiveness is we have to do this in an open system, because what's happening in proof of work and proof of stake networks, like we see it in Ethereum with Infura, where Infura is dominating MetaMask, and they can do an 80% attack on Ethereum anytime they want. Like the vast majority of fees that go into Ethereum are coming through Joe Lubin. And he's basically funding it. He's losing money on it because, well, Ethereum keeps going up. It's free money. So like one way to understand the Ethereum model is they're going to take Satoshi's volunteer provision model and they're going to make Joe Lubin the new volunteer, but he's making so much money from this arbitrage game on presenting Ethereum as a commercial network that he can afford to lose money on Ethereum. The proof of work situation in BSV is actually much more dangerous, I think, because what we're getting is we're getting TAL, which is throwing out proof of work, and they're saying, oh, it's a transaction processing model. So the flow of money into the network is now being consumed and controlled by corporate entities, and you're literally destroying the openness of consensus. And people will gaslight you and they'll say, don't worry about this. Like I've been in conversations with BSV developers where they say, like, oh, no, there's an incentive to share. And then it's like, why are you disabling access to their mempool? Like, like, why is it important to prevent people from getting access to the mempool if they've got an incentive to give away the data anyway? So all of that stuff flows from the need for the people that are providing the things that are of value to the user, especially on the network layer, to have a business model to pay for it. And if consensus doesn't give you that business model, you need the private sector to do it. And the private sector does not provide open for free. If it did, Amazon would be running IPFS for all of us, because that's what they're asking. What they will do is they will find ways to add closure to money and data flows, because they can't give away something and sell it simultaneously. But by having a consensus that pays for fee flow, we're paying for the nodes on the network that are facing users and providing them with data, and everything else flows from that. The guy on the edge of the network that's paying for this massively scalable data farm in California, well, he's paying for that, and the guy that he needs to connect to gets paid as a routing hop too, all the way until we get the block producer that's supporting things. So block producers might be full blocks, and then the guy at the edge is dealing with light blocks. But the scale of the network, what we're paying for is the routing equipment. And it's an inversion of the situation with proof of work. It's hard for people to wrap their minds around, though, because there's this libertarian and ideological perspective that, like, well, miners will pay for the network or they're not going to get paid. And, you know, it sounds convincing, but it's literally not how a free market works.
Right. You know, it sounds like you're really, what's incentivized is strong relationships between service providers and the source of fees, transaction fees, as well as their back-end relationships with the other partners. So it really is about direct relationships. You don't have this same orphan risk because of the 51% attack to worry about. It's almost like you're strengthening your existing relationships and connections, and you have an incentive to go ahead and actually be that broadcast network, because there's that gravity that's pulling you to actually share, because you're going to make more money.
Right, like you've got a reason to connect, and that reason is fee flow. And if I'm a central node and you're not driving me fee flow, why am I giving you massive blocks? And maybe this pulls back to Brittany's question as well, because it's like, well, what about scale? Well, one of the questions nobody ever asks in proof of work and proof of stake is, what is the value of a node on the network? No one ever thinks about that, right? And it's like, well, here's a question: what's the value of the network? they don't think about this at all. They're like, well, the value, you know, if you ask them about it, they'll say, well, mining has value. Well, staking has value, and they're not wrong. But the value of the network to the user is the fact that it's open and it continues to survive and it does what it's supposed to do, right? The value of the user to the network is that they're paying the money. They're paying the money that is incentivizing people to provide this service. So if you say, like, you know, randomly, what's the value of this node in the BTC network? There's a strong chance that that node is actually a leech. If we look at most of the nodes, people are really concerned about Ethereum's node count crashing. And, you know, I look at it, I'm like, well, most of those nodes are useless anyway. They're probably stealing bandwidth from a fellow node, consuming bandwidth from someone else. It's massively inefficient. So, you know, if those nodes actually provide negative economic value, they're actually hurting scaling. And one of the things you want, which is what Saito does, getting to the point you just made, is like, we actually are incentivizing people to have efficient routing paths. And that's actually getting rid of a Sybil, because what is a Sybil? A Sybil is a node on the network that's providing negative economic value. People don't think about it this way, but that's what it actually is. It's like, you're doing work and you should get paid for it, but because that guy exists, you're not getting paid your fair share. So, they're kind of big ideas. It's hard for people to approach sometimes.
You know, I have a real direct experience with what you describe, and that's what really struck me about the white paper, that as soon as I read it, this echoed right to my core of what you described about the free rider problem and how nodes are not incentivized to, they're not getting paid their fair share. And I'll give an example. Like, so I have a service called Matter Cloud, which is a BSV node API.
Yeah, I've heard of you guys.
And so for a long time, it was not a mining node. We spun off Matterpool later on. But at the beginning, something like 70% of all transaction flow was going through Matter Cloud, and we're mining, right? So the miners, the big miners, they're making all this money, and we're running this service that's for the network. And there's a direct pressure where, like you said, some of these like freeloader nodes, they would consume bandwidth, and there was a huge spike. And I was actually incentivized to disconnect other net nodes because the bandwidth was a couple $1,000s that month or whatever, and they were providing me value. But at the same time, it hindered connectivity to the miners to get those transactions. So there's like this opposing force, like a split brain situation. And I can see that the miners aren't really incentivized to share their mempools and to lower their fees. They have their own commercial interests.
Even before the split, the miners were all on Matt's fiber network, right? Like, you know, they might have, you know, they want maybe one node connected. Bobby Lee, I think at one point, he made a grand gesture of setting up a bunch of peer-to-peer nodes and stuff. Miners don't want that responsibility. Like, you know, if we go to economics, it's a free rider problem. The free rider problem is a public goods problem. And the problem there is private firms need to make money, but you can't make money if you're providing something that has general and diffuse value that everyone gets for free. Because, you know, you're bearing the costs, other people can get the exact same benefit without bearing those costs. So the private firms in this environment, if they either you're going to go bankrupt, or you're going to close access to stuff so that you can leverage that point of closure, whatever it is, to have revenue. And again, it's like the network you're going to get is not going to look like the network from Bitcoin's early days where it's volunteers doing it. And I think this is actually one of the most dangerous, and it's the craziest thing for us looking at the space. People don't think about this. And I think they don't think about it because they're not familiar with market failures. And this is really, like, if you read Menker Olson, he tells you what the market starts looking like. And, you know, one of the solutions is you get a big business magnate who's willing for people to kind of rotate around him. And that describes almost every scalable network that we're seeing right now. And the other solutions are monopolization and strong cartelization, right? Where there's like 3 of you guys and you police each other so that the other guy can't cheat you that badly. But if there are 3 of you policing each other, well, that's not an open network, because an open network means some guys should be able to join. And if you can police each other, you can police that guy, and you're not going to let that guy join. And the more people you let join, the weaker your ability to collude and police and protect yourself becomes. So yeah, it's a really deep set of economic problems. I'd also push it even more deeply, because we look at BSV and we see, there's also a net transfer from the entrepreneurs and the business people. A lot of people facing the users in BSV are super, super smart. And they're way ahead of where other people are because they're focused on on-chain data. But they're in this business environment where they're kind of expected to do things for free that generate money for miners. And it's like, well, yeah, that's not going to work. It's not going to scale. I mean, is it a huge problem? We'll find out. But the fact that you're complaining about a couple of $1,000 a month, that's not you're already at a point of scale where it's a problem. And BSV is not yet really at any point of scale. So.
Right. And
with Saito, you'd consume the vast majority, you'd consume the lion's share of the fees that came in through your infrastructure. So you could go to the guys that are free riding on you and say, well, look, if you can get me this much transaction flow from people, I'll give you data for free. If you can't, well, we're going to price your access based on how much you actually do give me. And you can, one of the reasons this preserves openness is you can always enter that market, because you can always start providing value and you can grow from that into a conglomerate if you want. You're not competing against someone like Tal, who's, they've got their private transaction flow and they're going to users. They're saying, use me, don't use that guy, because you're going to get faster confirmations because I'm the man. And maybe I'm going to orphan his block if you give him your business. So
I see that. And so with Saito, you don't have this incentive to erect barriers to entry to protect your cartel. Like Craig Wright has talked before, that Bitcoin at scale is a cartel. We're completely open about that. And so that's going to, like you say, restrict openness.
It's not a permissionless network. It's a cartel.
Yeah.
I mean, honestly, what's the difference between that and the Fed?
Right.
The Fed has what, 13 banks? How many miners are they talking about? Is money? No. Another thing is people, they put the decentralization, it becomes this fetishization. There's decentralization is network topology. That's not openness, right? There are tons of decentralized networks that aren't open and you don't want them. The people that are saying, hey, Bitcoin, we want this, we want non-cartel money. Yeah, okay, cue another rant there, but yeah.
On that concept of openness and growing usage, to tie back something you said earlier about how Saito is weaker with low transaction volume.
Yep.
So I'm curious what your perspectives are on how to get past this bootstrapping phase. I know with BTC, they put the block cap in when it was too small, it could be attacked. And right now, so what kind of this idea of what can developers do that bring transaction flow and transaction values? What would you say is the biggest opportunity for some of these smart entrepreneurs to take advantage of Saito to go ahead and nudge Saito's transaction flow over that limit to kind of accelerate the adoption? What opportunities do you see? Is it something like querying and indexing Saito blockchain? Is it maybe data store solutions? Where do you see it kind of entrepreneurs being able to swap themselves in to kind of accelerate the adoption and growth of Saito?
Let me answer that in two parts, because the first thing I want to say is proof of work and proof of stake are also very insecure at low transaction volume. Every single network, its work function is insecure at low transaction volume because it's the return on investment paid to the work function that incentivizes it. So, what we've got with proof of work is we've got this temporary block reward or this block subsidy that is pushing up security by pushing up the return on investment to miners, and the supply curve for hash power goes. What's going to happen with proof of work in 6 to 8 years is anyone's guess. I mean, one possibility is we stick with proof of work, but we keep hopping, we just keep coming to new networks, and it's like the entire monetary system is based on leap of faiths, coordinating which unsustainable network people are moving to next. So I don't think Saito is weaker than proof of work and proof of stake. The problem that we have, yes, we do need to get transaction volume up. One thing I'd say is, people that understand Saito and they learn about us, they really geek out because it's like Saito doesn't make sense until you understand it, but then you understand it and you go, well, of course, this is how you have to do it, or at least this is how you have to solve this set of problems that I care about. How do we get there? You know, people don't necessarily realize that we're a very young project. You know, like I'm a founder, Richard Paris is a founder, you know, we're a very small team. And if you compare this with almost any other blockchain, like we're underdogs in the space. So we're not at a point in time where we have massive amounts of money and we're flooding it out to devs and we're saying build this, or like our Rust client is at a point of maturity where you can really do the ambitious things that we want you to do in 6 months or a year. So, you know, it is taking us time. With that said, how do I think things happen? What I think happens is we're building this application layer that runs in the browser. And so we've got this JavaScript client that originally was the demo, and we've got a bunch of applications, particularly in gaming, that are there. But there's more. There's messaging. You can have Diffie-Hellman encrypted chat. I'd like us to get like n larger than 3 Diffie-Hellman, so we can get like Telegram and Signal, tiny encrypted group chats where maybe you do most of it off chain, but when someone changes their IP address, you get that on-chain ping, and basically we get Signal and Telegram without any central company. What's the roadmap? Well, what I'm hoping is that we find people who understand Saito, who realize what we can contribute to them and other networks, and there's just this, yes, it makes sense. So in the BSV space, I'd love for, as we get BSV onto our network, meaning in the Saito applications, this is part of our Web3 crypto thing, like you're making transactions on BSV, but you're doing it within the Saito application in your browser. And so maybe the games you're playing in the browser, you're paying a fee to a game publisher every game. And so we replace that business model where you buy the game for $50 and it's free play, and it gets replaced with like 25 cents or something. Maybe it's NFTs. We have an open source version of Magic the Gathering, and the cards are sitting on another blockchain as an NFT or something like that. We can do that. We can provide the application space. And I think that's going to be the starting point for people who are reaching into communities and saying, well, look, I'm going to provide this BSV infrastructure that allows BSV to be useful within Saito. And the other things you mentioned are good. Like, why am I using yours instead of someone else's? Well, maybe it's because you run a transaction archiving service. And so you go to the user that connects to you and you say, you want to use my access point, because if you are sending me transactions, when your browser queries me for your last 100 transactions, I'm going to give them to you. Like Google, I'm going to give you 100 megabytes of storage because you're sending me money. And so our growth strategy is going to be based around things like an advertising faucet. So token distribution with Saito is going to be, we've got to get this working, and we've got to get people who see the value and, iterating the application so people want to use them. And again, like this is kind of the thing we're focusing on application-wise. And then we turn on that advertising faucet so that people using the applications start getting token flow into their wallet. That token flow is used to make transactions on the network, and it creates the economic incentive for the people that are running the actual network. And so that's the desired bootstrapping model. We'll see what happens in real life. But it's part of our roadmap when we're expecting to hit this stuff. It's not going to be next week. We really are a young project, but I think as people learn what we're doing, the order in which we're doing things starts making sense.
That's really interesting that you used games and NFTs as the example to kind of bring transactions together and to distribute tokens. I'm curious if you think that this new model really works well for the metaverse concept. We're seeing many different blockchains and tokens built on Ethereum that they create games and game-focused blockchains. Do you think Saito has a specific or advantage of really enabling games? And it's interesting that you used games in the browser, and I imagine that's probably because of the incentive model really fits for games and interactive social systems like that. I'm curious if you could talk about how you see Saito would really really propel this concept of metaverse and NFTs and in-game trading. And if you could just touch on that a bit more
Sure. I mean, I'd say our view of gaming is a bit different in the kind of stuff we're enabling. Like, the original Satoshi Dice is essentially using the blockchain as a source of randomization for payouts. And so you're replacing the casino. And a lot of the gaming companies are basically, they're repeating this business model. So you get people who are doing that, where it's on chain, but it's provably fair and it's random because it's the block hash that determines things. I don't personally find those games very fun because I don't really think they're games. I think you're basically skinning a random number generator, and what's the point? We've also got a lot of the stuff that's happening on top of smart contract platforms where, like you say, it's a play to earn thing. I don't find that interesting either because I think that's basically, I think it's a group Ponzi conspiracy where I don't think it's fun. I mean, maybe it is. I don't actually have that much experience with a lot of them, but if your driving market for adoption is come and play this farming game and make money, well, that's not, it doesn't seem like a game to me. The reason that we have the emphasis on gaming is for a long time, we've been aware that we need to get transaction volume up. And really, how do we do this? It's serious. If we can't do it, we've got real issues as a project. There are solutions, but they're not good solutions because they'll require at least a temporary closure of openness as the network grows, and we don't want to do that. When we put up games, people kind of became interested. But the games that people play are actually they're P2P games. You're playing an actual human. So it's things like we've got board games. Twilight Struggle is a fantastic game. We've got an open source version there. We've got a game called Red Imperium, which is, it uses some of the mechanics from a really popular board game called Twilight Imperium. We've got, poker is always very popular, card games. And, you're not playing against a machine. The difference is you're also not playing against a casino because there's no trusted third party. So for us, it's not about an incentive model. In fact, one of the things that we're trying to do with the applications is we're trying to get the games to the point that we're getting organic growth without any pay-to-play incentive. Because when we get that, we can scale it up. But if we have to fall into a pay-to-play incentive, that's like, one, it's like lighting a bunch of money on fire. We're underdogs. We're a genuine open source project. We're not like Solana, Dfinity. Like, we're not going to do that. But two, we're not actually that far off. We are getting slow organic growth. And we're paying attention to like, well, what do people play? Like, where is the organic growth? Is it in the card games? Is it in the board games? What are the nature of the games that are attracting people? And we think that when we get that, that's like, we're iterating and improving the applications to iterate and improve that, because with that, we can execute the strategy. Without that, like you say, you're kind of falling back onto play to earn, and play to earn is just not, it's not scalable long-term. Or we don't think so, or it's a much bigger challenge.
That's interesting. So it sounds like different genres are possible, or different game mechanics are really going to excel in Saito, not just this play to earn, or
it's also differentiation, right? Like, and again, this is one of the things, like, people will come and play poker, but poker is not necessarily the really sticky game because you can go and get poker elsewhere. So there are niche games that get people coming back and back and back because they literally want to play that game. And originally, like, when we had these games go out, and you're going into a small community of people who are board gamers, and some of them are actually like, the blockchain was a liability. You can read some of the early reviews people had on Reddit where they're like, well, the game's okay, but I don't like this crypto stuff. It smells like a scam to me. And we're like, you can play the game for free. It's not a scam. But the crypto angle, really, people were suspicious of it. So yeah, I mean, but like a 2-player game, a 3-player game, a 4-player game. And then there's also the mechanics of how you design it, right? Because, on the blockchain, one of the real problems with application design is things like the immediacy of response for actions that need to take place immediately versus like hit a server and you get a cryptographic response. So, if you've got a game with trading mechanics, that's a real problem. And how do you layer on even human interactivity so people feel comfortable? A lot of it is, I guess you guys must deal with this with user, you're facing users, so it's a UI problem and a user adoption problem. It's not just let's implement consensus mechanism in Field of Dreams, hope people show up. So
I want to kind of go back to some technical stuff. You mentioned smart contracting earlier, like they're skinning a random number. I think you said with like some of these games, and I'm curious about some of the pros and cons and trade-offs with Saito's L1 ability for smart contracting versus like pushing some of that off on L2, and some of the rationale for that decision and that distinction between L1 and L2, and whether you're still evaluating how much to put into L1 versus L2 for being able to do on-chain scripting, such as like atomic swaps and kind of structures like that.
Yeah, I think on-chain scripting is the way to go. And I think EVMs have to be layer 2. I think there are some economic concerns about how much processing work you can throw at the nodes of the network with on-chain scripting. But yeah, I mean, one thing I'll say is this is long-term. Like if we start talking about EVMs, people are like, when EVM? It's kind of like when Binance. It's like, well, do you know how many programmers we have working on these problems? And we're working on like the blockchain level and the application stuff. So it's, we're ramping up and we're growing, but if we talk about an EVM, it doesn't mean it's coming next week. What I'd say is one of the big challenges with I look at proof of stake, and I think that what Vitalik did is he realized you could run applications on a blockchain. And then he took L2 and he crushed it down to L1. So now your entire blockchain is running applications. And as soon as you can attach data to transactions, what that data is, the layer 1 blockchain doesn't care about, right? What we've got is the L1, it cares about cost of attack, it cares about cost per byte, and it cares about like the economic model that is providing security and paying for the network. Layer 1 has no viable reason to care about what people are doing with the data that they're sending around the network. So what that says, it says, okay, well, you've got the layer 1. If you really want if you really want the EVM, code it as an application the same way the Saito Arcade is an application, right? It's kind of like when you receive a transaction, you can look at it and you can be like, is this for my EVM? And if it is, push it into the EVM. The blockchain is providing the ordering. The blockchain is providing universal distribution. So you can do this. So maybe I can throw it back to you and ask, like, you want to talk about scalability of this model versus layer 1 smart contracts?
In particular, I'm wondering if there's anything that's being left out by not having, say, a rich set of opcodes, and maybe they're adequate enough. But for example, in BSV has really focused on restoring the original Satoshi opcodes, and now we have things like basically transaction reflection using TX technique, and we're seeing some rich things.
I think it's one of BSV's strong points. I think it's one of the things that people really should pay more attention to with BSV. I think opcodes is something we'd love to have long term. I mean, we're not going to have them anytime soon. Who's implementing them? It's also that, it's that, I'd say that the problems that we're dealing with, because they're economic, are on, in some ways, it's on a much deeper level. And we're kind of like, look, well, when we can solve these and when we can come up from air, of course, we can look at opcodes, and hopefully we can learn from everyone's experience, and we'll be able to, have really good, really smart people who have experience say, look, this is how you have to do it. Of course, by saying this is what Saito is today is not saying this is what, we want EVMs layer 2. I'd love some, I'm not thinking this stuff through right now. It's more sort of like, well, this is the sort of thing that we're hoping to tackle in about 3 to 4 years. And it's not something I think we can tackle until people understand the economic and security model of the network. Because until you do, it's like, it's just totally confusing to people. Like we've had people who say you're running applications. Well, where's the EVM? And we say, well, you don't need an EVM. And they go, well, that doesn't make any sense. Well,
right.
okay.
There's the advantages and weaknesses to L1 and L2, and I've been a proponent of saying that you actually want both. You actually want to be able to, the application developer should be able to choose where their let's say their smart contract logic or application state lives, and I really like that Saito is thinking about the economics of that. There's an economic force to kind of I guess say guide the right decision without suffering the free rider problem and tragedy of the commons.
Maybe pushing you a bit on the fundamentals, because you just mentioned state, and that's a huge issue. Most EVM proof of stake systems, what do you have? You have a NoSQL database hooked up to the EVM. You've got massive state management problems. I don't think people know how bad it is with Ethereum. And your costs for supporting that are insane. And I mean, this is even things like reorg costs. One of the reasons I think that people are so enamored of finality, which is so destructive, is that if you have finality, at least you have bounded limits to the length of your reorgs, which means you have bounded limits to state management costs. If you're taking that and you're plopping it on something like Saito, like, one of the things we do is we don't have NoSQL, we don't have NoSQL. We don't use libp2p. A lot of these shortcuts that people use when they're building these projects, we can't use them. Like you can't use libp2p because if you use libp2p, it's like attaching explosives to the foundations in your basement because your entire networking layer is now going to be attacking you, right? Like, yes, please connect to me, take all of this bandwidth. And it's the same with state management as well. Okay, well, we've got a database, we've got this, your costs are now running, and all of a sudden people are like, it's an archive node, it's a full node, it's a pruned archive node, it's a light archive node. And like they use the words, and by using the words, they kind of rhetorically convince themselves that someone will do this. BSV also has the same problem with archiving nodes. They're like, the solution to this is archive nodes. And it's like, well, you don't have an actual workable incentive for that. You're foisting it on the private sector and ignoring what the private sector will do when it's asked to pay for that. But taking it back to Saito, by having a clean layer one, all we need is a UTXO set that's a hash map. And so we can use something super scalable like Google Dense hash maps, Swiss table, where you've got a key and you've got an int or something, which is like, has this been spent? And moving a block in, it's literally just flicking bits in that hash table. We can make it as fast as humanly possible. There's no database layer. So there are advantages, I think, to the design of saying, look, if you're managing state, it's got to be layer two. Not only technically, I want to push you a bit more by saying one of the real challenges is you can't even start pricing the services that the blockchain is offering when you start managing layer two app state. And what Saito does as people get confused a bit at ATR because they don't realize automatic transaction rebroadcasting is generating a market price per byte for on-chain storage by forcing transactions to compete. So it's kind of like a rental mechanism, but it's the world's first rental mechanism with a market price for rent on a blockchain. And as that works because the transaction is a certain amount of bytes in the transaction. And that's what determines the price. As soon as we have state and execution costs associated with that, well, does it break things? I mean, it clearly breaks things, but does it break things badly enough that things screw up? And like, it's kind of like the sharding approaches where theoretically it works and then everyone puts their application on one single shard so that it's, immediately responsive with the stuff they want to use. I don't think that I think that at scale, every incentive problem gets worse. And the bigger you scale, the worse the incentive problems get, because an incentive problem is an opportunity for extraction of wealth. And so even small ones you have to be careful about. And because of that, I think I'd need to be convinced that layer one state is a good idea at all. Because I think it's mostly a bunch of negatives that are sold basically on performance. And I think, layer two on Saito is going to be more performant over time. But, saying something like that, and it's current year, not current year plus N. So
I'm glad you mentioned the ATR, automatic transaction rebroadcasting, which is backed by the circular blockchain. And
yeah.
I'm curious how your thoughts on the upgrade path, the protocol upgrade path. You talked about adding new functionality later on, and what does that kind of look like with these distributed participants and like all getting on board with the version of the node that would kind of drive this? We'll call this the full-blown Saito in a few years. How does that governance work? What are the incentives for participants to upgrade in a timely fashion? Will they want to write their own nodes to kind of move the network along? I'm just kind of curious about how the network will get upgraded and how the governance is going to get it to that destination. And along that path is how scalability will also be increased. So that's a bit of a double-sided question there. Is how do you envision governance will work? Is there any downsides to?
We have no idea. I mean, it's one of the counterpoints of openness is if you've got an open network, it's possible to fork it. So, I think governance. What is the upgrade path? We're expecting that we, as kind of the developer and the protocol development team, will be playing an important role for the next 5 to 10 years. And we lock down the protocol at some point. And at that point, it's like, well, okay, what happens? I think the fact that the network will be consisting of people that actually are incentivized to scale. The incentive is to scale up until the marginal cost of accepting a new transaction is higher than the revenue paid by that transaction. That's what the looping chain does with its competition. Because one way to think of it is you have to do all of the work before you get paid, which is the opposite of proof of work permanent ledger, where you get paid right away. And of course, there's no incentive for you to care about accurate pricing. So, the block size debate, et cetera. Some people get this. It's hard for other people to see. Getting on to governance, there is an incentive for people to make changes if that keeps the network at the technical boundary where they can expand transaction flow. I mean, we don't know how this is going to work. This is like talking about Bitcoin 15 years out. The incentives point us in the right direction. The one thing I would kind of highlight is governance. When people talk about governance, to me, it's one of these traps like decentralization, because Saito is a free market blockchain. We do not want closure because we don't want the state. Governance is the state. Governance is closure. And we look at things, and people basically, maybe because it's computer science and distributed systems, what we've got is we've got a lot of techno-libertarians who are convincing themselves that their form of closure is free market based because they're well-intentioned. And we get some situations like Vitalik is going crazy about quadratic voting and how this is the solution to public goods. And it's like, no, it isn't. Like, it's not a solution to public goods unless you have someone who is choosing the only people that are eligible for payment. It's a practical solution in some senses if you want to do that, but you've got to add closure to solve the public goods problem. So it's like, it's a state solution. Because if you have this active closure, well, why don't you just let them choose who gets paid? It's kind of the thing going back to Leslie Lamport's solution and Satoshi's solution. Satoshi's genius was it was an open mechanism. Anybody can come and participate. And all of the previous solutions, you had someone deciding who gets to participate. And it's like, well, if you have someone deciding, why don't they just decide what consensus is? So, I would give pushback on governance. We don't really think about it. And I think it's kind of, I think it's a red herring. That being said, I think the things you said, we don't necessarily have good answers for them. But I don't think we're in a worse place than other networks on that as well, because I think the incentives do push us to maximizing throughput, certainly.
It's interesting that you said the comment about proof of work, you get paid up front for working at the tip, and you may have not done the past verification work. But with Saito, the only way that you can participate as a block producer is by doing the work up front.
Yeah.
Just because of the nature of the UTXO set, how things are, in order to produce a valid block, you have to know that. So to me, that's very interesting, because it kind of goes back to this BTC, what do you call it? The running things on Raspberry Pis,
Yeah.
having as many nodes as possible, because you got to verify your coins yourself to protect the network, which is just a kind of an empty gesture. It's all feel good, doesn't actually add anything to the security, but there's definitely like real like peace of mind people get with that. But what's interesting, what I really like about Saito is that the block producers actually have to do the work, and you actually need to be able to have the entire circular blockchain loaded up and verified to be able to actually be an active participant. I think that's like a real strength that other blockchains completely miss.
I'd love to push you on this, because this is one of the things where the people that get it. We're coming out and we're saying, look, guys, this is an economic problem. Now, what you've got, this is the tragedy of the commons, right? The classic example is farmers putting sheep on the pasture, where I get money and wealth today, and it's socially destructive, but I do it because I get money today. And everyone does it, and we degrade the commons because it's immediately profitable. And so we're privatizing gains and we're socializing losses. And, blockchain people get really confused by this, to the extent they're libertarian, because we're talking about market failure, and they're like, there are no market failures. And what they've done is they've internalized the economic problem as a technical problem. And so they start talking about block size. And it's like, your problem isn't block size. Your problem is miners have an incentive to put too much data on the chain. If you can get rid of that incentive problem, you don't need to worry about block size. You will emergently go to the good block size. And because they don't see the problem as a market failure, they don't even start thinking about, is it possible for us to solve it? And then the second thing is, because they're ideologically committed to the permanent ledger as if it's some sort of thing, like you can follow a chain of hashes in both directions. It's like, there's nothing about the Genesis block. The Genesis block is locked to the software. It's like, you can do whatever you want with it. You need to have an anchor point. But because their anchor point is conceptually with this one particular way of doing things, they lock it in as they can't even generate pricing. And well, if you can't generate pricing, miners can't calculate what's profitable. If they can't calculate what's profitable, you can't have a system that fixes that incentive problem. So you're totally right in the description of the problem. I just wanted to push you a bit and say, it's one of these really powerful things, because the free rider solution we have works in the same way, but it's really hard for people to see, because what we're doing is we're saying, well, if you've got to have, like, hashing, we can objectively measure it, and so we can pay for it without being gamed. And what Saito needs to do is it needs to turn the provision of value to the user, and the user can be another node in the network that's collecting money and routing it through you, into something we can objectively measure, so that we can use that as our work function. But what's actually happening economically is we're assigning a market price to the value that the blockchain pays for. Consensus, because like, people don't think about proof of work as a Stalinist solution, but it's literally Gosplan from the 1920s. Gosplan was the Soviet Planning Commission. It's a bunch of technocrats who are saying, we're going to pay 100% for mining and 0 for all of these other things, which is pretty much the same as we're saying 25% for milk, 10% for bread, 50% for toothbrushes, right? Like, people don't notice because something gets all of the money and everything else gets nothing, but you're still doing price fixing, because price is the relative value that your network is paying for stuff. With Saito, the market is picking the relative value of the stuff that it's paying for, because it's not measuring it directly, it's measuring it indirectly by saying, we trust the users will only pay more money if someone can convince them to pay more money. And if you can convince someone to pay more money, well, you're providing more value to them and to the network. So we're going to pay for that. But the point is, it's the same thing. It's that tragedy of the commons thing, where you can look at it as a technical problem. And you can look at, how do we pay for the network? And you could say it's a technical problem. And if you approach it as a technical problem, you get the BCH solution, which is garbage. You get the let's have a subsidy for masternode solution, and it's garbage. If you approach it as an economic problem, which is much, much harder because it's cognitively difficult for people in the space, you can actually get something that works. And this is why Saito's solution is so exciting, because there's literally nothing else in the space that's anything like it. Anyway, so we get really excited when we get to chat with that.
You know, I have a specific question I'm curious about of how this works technically with what you said about this being an economic problem. And I get the impression it's because it's a circular blockchain and you have this automatic transaction rebroadcasting, and the circular blockchain is almost like I don't want to say ephemeral, but it's like a moving cloud of particles. I kind of think of it as like anchor points, but you can always trace it back to the genesis. Someone that cares to archive everything could do that, but that's their own prerogative. It's no longer necessary.
Yeah, and you can do it. You can do it with header hashes. You save the header hashes, and you can always demonstrate that any SPV, whatever, you can demonstrate that this transaction at this point in time, it's a data archiving issue, but the nodes in the network don't need to. It's that what it really is it's that we're guaranteeing that the spendable UTXO are at the tip of the chain. So, there are issues in scalable chains where, like even BCH, they're talking about UTXO commitments, right? Where, they're saying people aren't going to sync from the Genesis block. And it's like, well, if people aren't syncing from the Genesis block and you've got spendable UTXO back there, you could be an OG with a ton of spendable cash. And when you make that payment, you've now got to wait for someone who's indexing that to produce a block. And God knows how long that is, because who even knows who's indexing it? Right. It's not worth at massive scale, it's not worth their time or their money.
And that's the biggest advantage amongst many. One really big advantage is that Saito, anyone producing blocks must validate the UTXO set, the entire circular blockchain in that epoch. And with other blockchains, you have to go back from the beginning, because otherwise you have to trust some UTXO commitment, and then you get back to that.
They don't. I mean, what happens is people cheat. And we've seen this repeatedly in proof of work and proof of stake networks, where the block producers don't behave the way they're supposed to. People aren't validating stuff. And you make an older transaction, it just takes ages to get confirmed. I think the stat I read was that like 90% of BTC UTXO have been made in the last 3 weeks. So, well, at massive scale, why the hell do you care about the long tail? Is it really, profitable? Especially when we start getting to petabyte blocks. And who's even going to give you that data? And what's the profit from doing it? We think ATR is the obvious thing to do. The challenge there, I think, for people is seeing it as an economic problem, because it's a problem about price measurement. And that's really the switch, because by forcing people to do the work before they get paid, you prevent them from passing costs into the future. But you also give them the internal expectation of what their profits need to be. And if their profits, they're not going to accept stuff that pays too low a price. But they can also increase revenue by shrinking the blockchain if costs are rising above the marginal payment. And so if they shrink the blockchain, you're reducing competition from users. It's actually a market solution. If it gets too expensive to have a big blockchain, block producers will dynamically shrink it, because that will actually increase their profits, because it induces new transactions to pay more, which induce old transactions to pay more. So it's great. There's a market mechanism. One of the questions we don't know the answer to is, should we actually have a block size cap with Saito? Because it's somewhat radical to say, well, in theory, this works, let's not do it at all. I don't know if we're that brave.
That brave to be unlimited, or?
Well, we've got software constraints too. Like we're developing a network. I'm more saying these are the really interesting discussions. I think once people understand what we're doing and how the network works, you can do pricing, and the incentives are pointing you at the right direction. It becomes questions of, is the market actually rational? or to what extent is the market rational? We believe the market is bounded rationality. I'll go with. But yeah, like under development, we're likely to have increasing block size caps because bandwidth, and we don't, we'll see. But interesting questions anyway.
I'm curious if there's some use case or something that's some new kind of application that's enabled that you have on your mind that that you'd want to reveal for someone else listening that would really be able to take it and build on Saito. Maybe don't have to give away your favorite pet idea, but is there some kind of a
take it? I mean, what we need, what I think is going to be transformative, is n is greater than 2 Diffie-Hellman sigs. Right now, if you go to Saito.io arcade and you add a friend, when you add a friend, you're actually initiating a secure key exchange, as long as their public key is correct, which is kind of like as long as you know their name. There's no man in the middle attack on this. It's fantastic. At massive scale. Like people are like, oh no, there's a man in the middle attack. Getting their public key, someone could be in the middle of there. And it's like, well, yeah, but that's like I'm trying to add Bob and someone is pretending to be Bob. The challenge is on a network, which is, again, it's why a universal broadcast network. I want Diffie-Hellman n is greater than 3 so that like 4 people can create a secure group chat and we can get rid of Telegram. We can get rid of Signal. We can do that at whatever level of security we want. I think there's, you talked about the transaction archiving service that you guys are kind of looking at. That's how we get Facebook. That's how we get Twitter, right? Like my Facebook posts are wrapped in the transaction and I store them with you. And what do I send my friends? I send them the SIGs that authorize them to unlock the post about my love life. And then my relationship economically with you, like, well, why do you give that data to my friends? Well, you give that data to my friends because I'm paying you transaction fees when I use the network. And we can negotiate that. So yeah, I mean, there's a ton of stuff. I'm hoping gaming comes along. I personally like games. It's a bit de-stressing, but there's a lot to do. I'm also hoping that one day we wake up and we find there's a lot of transaction volume from like a 12-year-old in Mexico. And we're like, didn't see that coming. Like Flappy Bird on the blockchain. Knock on wood,
It's all definitely possible. I'm really enthusiastic to see where the project is going to be in the next year or so. And I'm sorry I didn't get to speak more. As you guys were discussing, you touched on a lot of the things that I wanted to ask about. 51% attacks and the free market and the free rider problem and everything. The only other thing that I was really curious about is we touched on proof of work and proof of stake. And I was curious how Saito compares to, like, say, Solana's proof of history, something other than like just proof of work, proof of stake. How does it compare to the proof of history?
Like when you're in the blockchain space, people always say, how does it compare to X? And it's like, I don't know the details of Solana in order to be able to comment in really an educated fashion on this show. My understanding is that the problems they ran into were triggered by Scale tracking the leader. Saito shouldn't have that problem. They've got, the issues that we're focused on solving. I don't see any solutions there. A lot of the people that are doing consensus work, they're going back to the 1980s. They're going back to like Leslie Lamport's solution to the Byzantine general problem, right. 1982. And they're using like validator approaches and they're kind of gaming how the network topology works, like how many participants there are. And it's a consensus mechanism usually wrapped by a proof of stake mechanism. And that proof of stake mechanism, what it is it's the act of closure, the selection mechanism that Satoshi solved by making open. They're not paying for the network. Like there's the guys at Near had a wonderful deconstruction criticism of Avalanche, and you know, as soon as you've got people paying fees in that, the incentives are not for honest behavior. People don't think about that. Does it matter is a really good question. You know, maybe networks like this will just become corporate and people will want to use them. And it's like permission networks versus public blockchains. I think that's where Solana is going to kind of head to. The economics of it suggests to me that it's a fast consensus mechanism that works if you've got a couple of companies running it, and that incentivizes only a couple of companies running it.
Right.
We'll see, you know? Like, we're focused on a different problem set. Our problem set is that, like, the free market doesn't do stuff for free.
Right.
And the fact that we're in the crypto space, you know, people aren't focused on that. And it's a huge problem. I think increasingly people are aware of it, though. And that's why in some cases we're getting this doubling down on the decentralization kind of fetishization, because asserting that decentralization is a solution is a way to avoid looking at the problem. So,
well, I know that we've had an excellent conversation here for the past, but I know we're getting on in time. Yeah. So I want to go ahead and start wrapping this up. But Attila, I wanted to switch it back to you real quick and ask you if you had any final thoughts or questions for David here.
I think that the biggest thing for me was to understand you know, the economics and the differences between Saito and the other blockchains, and it seems like really with Saito, you have really thought about the economic problems right down to the core. And so to me, that really resonates with, like, me as a Bitcoin service provider of being able to, like, pay for the funding of the network. I think is, like, directly spot on. And I think from my understanding of the Saito blockchain, and there's really, I think, really unbounded scale. And this is a protocol that will scale to, I think you mentioned 100 terabytes before per day. It's totally, like, within the realm of possibility.
It scales with bandwidth and networking. You know, how big the blocks are, what the block size is, you know, latency of relaying. I think, you know, what you said is just dead on. It's the difference between a consensus mechanism that pays for an extractive form of work and a consensus mechanism that pays for a contributive form of work. And for scale, we need money. And we need the money to go to the people that are doing the contributive work of servicing users and getting money in. You know, it's like you say, it's on that level. And, you know, in Saito, you guys are the guys that are getting paid.
That's great. And I just, the question I'd ask for other developers and entrepreneurs, like, where would you recommend they would start? Would it be like the white paper and really understanding that economics? Would there be some links or any resources that you really recommend that for people to build that N plus Diffie-Hellman exchange?
You know, I'd ask you. I think the one that has worked for people the best is a YouTube video called Openness, Not Decentralization. Because I think a lot of people have trouble seeing the problems and seeing what we care about. Because people are like, well, Mimblewimble, I can exchange tokens, or, you know, Lightning Network, I can make a payment. You know, like, what are you guys even working on? We're trying to figure it out, how to communicate with people. I mean, what we care about is open and permissionless data networks at scale. And a lot of people don't think about that in crypto. They're like, I'm speculating on
number go up. Number go up, we get rich.
Look at Binance Smart Chain. I mean, that's a corporate chain, and people are like, "Oh, I love it because it's cheaper than Ethereum." And, like, that's our future. Our future is public open blockchains. Is, you know, right now we're in this we're in a protected arbitrage regulatory space where Google and Apple aren't running this stuff because they realize the government's going to, like, take them out. But as soon as Google and Apple and Baidu, you've got a 3-person consortium, and it's, well, this technology is not money, so it's unregulated. It's like, well, it's open season. And why would anyone use a public blockchain that pays for miners and stakers when you don't need to pay for miners and stakers if you're on corporate chain? People, I don't think they think about this stuff yet. I think
not yet. I think it's coming, though. I think you're right on that. I think it's just a matter of time before people start paying a bit more attention. My thing is, I think it's going to be a cataclysmic event in crypto that kind of pushes people to be like, well, maybe I should be looking at the other side of this. How does this work? Instead of just, oh, does the number go up?
And it's going to be done. It's going to be done for everyone's benefit.
Oh, I absolutely.
We're going to have inflationary policies because it's what's in the best interest of the network. All of this stuff, it's for you.
Oh yeah. Well, until it's not.
So basically, save the future of blockchain and open networks by watching that YouTube video, which I agree. I watched that video, Openness versus Decentralization, to really help me understand it with the white paper. So I think that's how we're going to save the space, is with people starting there. At least that's what worked for me.
Fix the routing side, use the open networks and the things that others can do. And we get a really strong TP there. And yeah, it's going to buy us, it'll buy us a couple of decades, I think. And I don't think anyone knows what the eventual kind of hybrid merger of all of this stuff is. But we'll find out.
It's exciting.
Anyway, thank you guys for having me on. And honestly, thanks for a really substantive discussion and letting me rant. That's great.
I fully enjoyed it. I can't thank you enough, David, for coming on. And Attila, thank you so much for helping me co-host the show today. Your questions were great. You led them into the questions that I wanted to ask. So I thought the conversation flowed very, very smoothly. And I thank both of you guys for helping me produce this valuable content today.
Thank you both. I really
appreciate it. Thank you very much, guys.
All right, guys. Well, that is going to wrap it up for us today. Please make sure you hit the like and subscribe button. I will leave links to everybody's information down below. But with that being said, we will see you next time. Bye-bye.